All righty. So I'm going to go ahead and share my screen. It is this screen. Okay. Can you see my console here?
Yep, looking good.
Okay. How's that for size? Do I need to go bigger than that?
Looks good.
Okay. I'm going to go here into a finished version of this little project and show you what we are going to be building today. So this is just basically a walkthrough. There's a repository, which I'll show you in a second, but we're going to be building this. So if this all works, ooh, I have to go slightly smaller so we can see this. Can you hear the sound?
Yep.
Okay, hold on. We'll go a little bit smaller on this thing. Let's try it again. It's got to be, whoa. Oh, the UI is telling me other people are joining. Do you want to admit them? I'm sure there's some setting somewhere to just say admit them all. I don't need to like click a button, but welcome newcomers. We're just getting started. Just getting screen sizes and stuff correct. All right, let's give this a try again. So this is what we're going to be making today. It's a little terminal game. Just got some characters here. I've got a little guy with a sword. The red thing's a sword. Those are monsters. We're going to go fight them. So I kill the monster. And hopefully I don't get killed. And when I do get killed, it ends. So that's what we're building. We've got sounds. We got a bunch of other features. It's super simple. It's almost all pure Rust in a sense. We use a couple libraries, but like the code we're going to go through is just Rust. So let's see. I think we can make this like 2 ticks bigger or something. All right. So first things first, let's get a browser window up from somewhere. Pull it over to the screen. So on GitHub, I am clean cut and Rusty Sword is the repo. So if you want to come back later, all the code is here. We're going to be sort of rebuilding it today. If you're on Linux and you want to run this yourself, there is one dependency for the Rusty audio crate that I use that you have to install. But other than that, it should all work out of the box on Windows, Mac, and Linux. Okay, so there's the repository. So let's go on and just get started. So we're going to go cargo new Rusty Sword, get into it, and then I'm going to use IntelliJ today. I'm always on the lookout for the best IDE at the moment. I need to give VS Code another try and see how it's doing right now, but I'm on IntelliJ right now. Hopefully, yeah, that should be big enough for you all to see. That's as big as our terminal code over there. Okay, so we've got here our project. It's just blank. I'm going to go ahead and preload this with all the dependencies that we're going to use. So the dependencies are, we're going to use Crossbeam. So this is the channel library built by the Mozilla folks as part of Servo. And then we're going to use CrossTerm, which is a terminal library. And I'm going to use an older version just because I didn't check to see if the newer versions, how it changed. And so I'm going to stick to this older version for now. I didn't realize I was going to be doing this presentation until recently. So, and then we're going to use the RAND library for random numbers because it's a game. You got to have random numbers. And I made a little crate called Rusty Audio. Let's see if it auto-completes. And we're going to use that to make audio simpler. And that's it. And so now that we've added those, I'm just going to go over here and go cargo run just to get the dependencies downloading and building in the background. And I'm just going to run in debug mode. Our thing is simple enough that we should be fast enough. Although, you know, for a real game, you definitely want to be in release. All right, let's get this guy a little bit bigger. Oh, and by the way, anyone, please feel free to stop me at any point. Like, this is our user group. We can talk about stuff. If I don't have the answer, I bet somebody else in the group does. So Yeah, feel free to stop me. If we go through this entire thing end to end, I expect it to take a little under an hour and a half. If that's too long, I can copy and paste in some parts of it. We can skip. That's fine too. Or we can go the full 2 hours. All right. So moving on. Now that we've got the modules going, let's go back and, oh, let's see. Now that I'm full screen, I have to do this thing, don't I? I'm going to go ahead and just, since I know the layout of this, I'm just going to create all of the library files up front. So I'm going to go into source, and I'm going to want a lib.rs, obviously. And then let's see, we're going to make a coordinate struct. So we're going to nicely organize this into modules. So coord is for our coordinate. We're going to make a floor to represent like that square floor of walls that we're standing on. We're going to make a monster so that those little guys chasing us are all sort of self-contained. We're going to make a little player, that's us. We're going to make a render module and actually have that run in a separate thread. And we are going to make a timer to use for timing things. And we are going to make a world, which is going to be a super simple struct that just gathers all the rest of it into one place. So I'm just going to touch those all real quick and then go back over to IntelliJ and go into lib and sort of the same thing. I'm going to be like coord, floor, monster, player, render, timer, and world. Go here and get in the right place and go to pub mod. So they're all going to be public modules in our library crate.
So is that for re-exporting them?
Yeah, this is just for tying the modules to the library so that we can use everything nicely as a library.
Okay.
And
actually,
yeah,
re-exporting them would be a pub use later on. This just adds them as part of your project.
Good point, Levi, thanks. And, you know, I don't know if everyone realizes it. It took me a long time to understand this, but your library is a crate, and every single one of your binaries is a separate crate from your library and from the other binaries. So like if you try to do the use crate something, it's got to be within the same binary if you're in the binary, or it has to be within the same library if you're in the library. Library I expected. Binary, I was surprised I couldn't use that from within my binary. All right, so let's see where we're going to go next. Also, let's do one last sort of bit of housekeeping in the, okay, how do I get to my browser from here? There we go. Maybe if I make that full screen, I can swipe between that. I'll zoom a little bit. Okay, so in the browser, if we go to Rusty Sword, there's this clips subdirectory, and it's got 3 sounds. So I'm going to download those. I'm actually just going to go ahead and cheat, just copy them from the finished version. But you could, if you were doing this, you could download them or whatever, or make your own sounds or whatever you want. So I'm going to go Rust, audio, clips, and that needs to be cursive. What did I do wrong? Not Rusty Audio, Rusty Sword. Too many Rusty things. You notice I'm not super imaginative with my names. At least not for teaching purposes. Everything's Rusty something. All right, so now we've got, let's just take a look real quick. So we've got our clip subdirectory with our wave files, with our sound effects. I use BFXR, just a little free sound clip generation utility to generate these sounds. Sort of fun. If you've never done it, I encourage you to check it out. BFXer. And then we've just got our other stuff. Let's see, let me go down. Whoa, we got target already, so that's not gonna work. But still pretty simple. Okay, so now we're sort of at the skeleton part. So if we just go run, it should all work. Dependencies are already compiled, which is an interesting trick, but I think it's something they ought to fix in the future. I think if you don't use a dependency, it shouldn't bother compiling it, but you know, someday. And then next. Okay, next step. let's go ahead and set up audio handling. Okay, I'm sure there's somewhere for me to reorder these so I don't have to go through that every time. Yeah, there we go. Okay, so let's go back to main. And we're gonna change this hello world to something a little bit more fun, like thanks for playing, because this is gonna run at the end. Let us know we got out cleanly. Before that, we're gonna go ahead and make a mutable audio, which is an audio. And this is where I like IDEs, just auto importing it. So Rusty Audio has an audio struct. It represents the entire audio subsystem, and it actually uses threads and rodeo in the background. So we'll be using threads at this point. And then the interface is we give it a name. So it's something like monster dies, and then we give it a path to our clip. So clips monster dies. And then we do the same thing for the other two sounds. And I need to hit someone joined. There we go. Hit admit. Welcome, whoever just joined. Okay, so then we go ahead and change these. So let's see, we got monster spawns. And player dies. And that's all the sound effects I got around to making. So let's go ahead and give it a try. We'll go audio play monster spawns. Now this will launch the actual playing in a separate thread. So it'll return execution here instantly. So if we want to be able to actually hear it, we need to wait. So there's actually a audio wait helper that will just block until all sounds have stopped playing. So I'll just go ahead and add that. And then we should be good to try it out. So go run. Uh-oh, what did I do wrong? Couldn't find audio file to add. Oh, I think I was in the source directory when I did the clips thing. Yep. Let's try it again. Okay, you able to hear that?
Yep.
Yeah, sounds great.
All righty, next step. So let's go ahead and remove this for now. We'll add something back in pretty soon, but let's make a game loop. So let's go, I'm gonna label it because we're gonna wanna be able to break out of it. So game loop. And then we're going to start using cross-term for some terminal fun stuff. So it's our game loop, and we need to get an alternate screen. So cross-term has this cool feature called alternate screen that you may have noticed, like if you launch Vim in a terminal, it switches over to Vim, but when you get out of it, it goes back to what you had. That's because most modern terminals have an alternate screen function. And so we're going to trigger that function here and ignore the error, because if that doesn't work, then we just don't want to use that crappy terminal.
Most classic terminals do.
Most of the classic terminals do too?
Yeah, it's a carryover from like the VT100s and whatnot.
Sweet. So it's going to work for everybody then, hopefully. All right, and then we also want some way to get input. And so that is terminal input. And this is where there's some bug in the IntelliJ Rust thing where it won't automatically get that one for some reason. So I have to go manually add that here. There's still problems if you got like a feature flagged macro or something like that that doesn't always get the imports. So it's called terminal input. Then let's see. So also this true here, that is for raw mode. And that makes it so that when we push a key, the terminal will let us read that the key has been pushed instantly rather than having to push enter each time, because that would be really tedious to be like left, enter, left, enter. That would be really lousy. And this is still not going to be a fantastic input mode. Like it's going to be dependent on your keyboard input rate, but it's better than having to press enter. And speaking of which, let's get that reader. So got to be mutable because it's got its own internal state it's going to modify, and that is input read async, because we are going to get stuff if it's available and move on. We're not going to block. And then let's do it. So while let's event is reader next. I probably should have used some iterator or something like that, but.
So what trait does the reader implement that we're going to be using for the reading?
I think we're actually using an iterator trait.
Oh, okay.
If that's what you're asking right here.
Oh, yeah. I was wondering if it implemented read or something like a read async trait or something.
I don't know. And
I have a quick question really quick. So I was
yeah.
trying to follow along with crossterm, and I was trying to find the alternate screen. Are you using an older version of crossterm?
Oh, yes. Did you join after that?
I joined late. Sorry, I was shopping.
No worries. Oh, yeah. You know, that's where I would be right now if I weren't doing this too. So like the current version is like 16 or 17 or something like that. But I brushed this off at short notice, and I didn't get around to actually updating crossterm to the latest.
Okay,
and I
no
learned
worries.
not to try to do that adjustment in the middle of a demo. So I backported it to 11.1 here.
Okay, great. Thanks.
So
Okay.
I've got a question on that loop.
Yeah.
What was that apostrophe kind of thing before the label?
Okay, so this is a loop annotation that gives the loop a name. So now if I'm in a nested loop like this one, right? So here's a
can
while
break
loop
out of
inside
it.
of a unconditional. Yeah, I can break out to the game loop. And that's what we're going to do in a minute.
And you need that apostrophe? Is that?
Yes,
never
it's
seen
part
that.
of the
Okay.
syntax.
Okay,
It's
okay.
a bit of an odd syntax.
Thanks.
Yeah, no problem.
I have a question real quick.
Yes.
Since reader is an iterator, couldn't you just use a for loop right there? So it's like for event in reader. And it would
That's very possible. That's very possible. Like I said, this project actually was from 3 years ago, and it was in Rust 2015. A lot of things were different back then, and I was much more clueless with Rust at then. So I haven't updated every single construct in this demo. I apologize. But yeah, you probably could use a for loop or an actual iterator with some functional style stuff with some closures. There's a bunch of different options. Good question. But yeah, I'm like manually while looping through the iterator's next method. So
that is something that I've seen done before for various reasons. Sometimes it's just some part of the iterator API just doesn't mesh with it, and so you just have a manual next.
Yep, and it
I
gives
don't
you
know if
like
that's
the
the case here,
flexibility.
but I've seen it before.
Yeah, and it gives you the flexibility to like stop and go do something else in the middle of your iteration, and then come back and continue by calling next again. So yeah.
If you, for some reason, if you wanted to like call next of again in the middle of the loop, like sometimes you're going to like go over 2 iterations in one or something, like for some reason you could do that in this syntax where you can't do that with a for loop. So like they said, there's other reasons.
Yep, this is definitely lower level. Okay, so on our event, I had to look this all up. I mean, there is an enum here encompassing another enum, event, as characters. So what I'm doing here is I'm making some way for us to quit. So if we press Q, let's quit. Or if we, let's see, I'm not quite the right place. Or if we press escape. So let's make 2 ways to get out of it. If we press Q or escape. So input event, man, like the intelligent, keep looking for it to be able to autocomplete, and it's just like not doing it. Why at the moment. And here's the place we want our break game loop, right? And semicolon sort of optional on a break. And then otherwise, we're just going to not do anything at the moment. Okay, let's see. Let me close this so you can see the whole width. So there we go. So we're looping through the events we get from the reader. So this is the async reader. So when we hit the end of the currently queued input events, it'll just give us none, and we'll be done with this while loop. Or if we get a queue or an escape, then we'll also be done. And we got to get these things imported. Let's see if it'll, no, it won't find it for us. Okay, then manually. Try it now. Now is it happy? Closer. Oh, probably be better if I spelled it correctly. There we go. All happy. Okay, and then at the end, right here, this would actually print to our alternate screen and then immediately exit, which would drop our alternate screen here and switch us back to where we were. So we would never be able to see this. So I'm going to manually drop alternate screen right here. And then we'll be back in our previous screen for the print statement. So let's give it a try. So clear, cargo run. Okay, it cleared, it went to the alternate screen, which is blank. So if I hit Q, we're out there and there's the thanks for playing. If I do it again and I hit escape, hurrah, I accidentally hit like F1 or something as well, but all right.
So
that's working.
The drop statement doesn't that call a method on alternate screen? So is that basically it allows it to call a private drop method? That's
actually really interesting. So the drop method or the drop function itself, here's the implementation right here. For an X
this
of
is
any
one of my
type,
favorite functions of all time.
do absolutely nothing. I'm taking you by value and then you're going out of scope and so you get dropped. And then implicitly, Rust itself will call the destructor if there is one, pop stuff off the heap if there's anything on the heap. I'm sorry, free stuff off the heap if there's anything off the heap, and pop your stack portion if there's anything on the stack. So yeah, that's part of.
And how did you pull that up so quickly?
Oh, it's on the Mac, it's Command Option B when you're on drop.
For IntelliJ?
For IntelliJ specifically, that's an IntelliJ feature.
Okay.
Cool. Although actually so you'll get that if you have any editor that uses the language server protocol. So like I have an Emacs, I can do a similar thing. I'm not 100% sure if it works on all like built-in stuff, but it'll at least work on the functions I define. So
yeah, it's pretty cool. And like it actually shows, at least in IntelliJ, it shows you like exactly which source file it's looking at. Anyway, okay, awesome. So let's see what's next. Oh, let's do time handling now. Okay, so let's go back over here and let's make a timer struct. So timer is important in games. We're going to use a timer to know how often to spawn a monster, how often a monster ought to move, and things like that. So just sort of simple stuff. So we'll go pub struct timer, and we're going to have a time, which is going to be a duration. That's our one import here. Thank you. And then we got time left. So the difference is time is the time that you start at and you count down from. Time left is where you're at right now. And then we got a public, remember, ready, which is going to be our Boolean. That means the timer went off, right? And then there's a million ways you can implement timers. This is just the way I did it for this project. So don't hold it against me if it's not the fanciest. Let's make a public associated function. We'll call it from milliseconds. So I got my milliseconds. Let's have that be a U64 because that's what they are when you get them from the time module. That's going to return a self because this is like our constructor. And our duration to duration from milliseconds. And with our milliseconds, and that's why I chose U64 because that's what it wanted there. And then we're going to return ourself, which is going to be our time, which is going to be duration, and our current time left is also going to be our duration, and then ready is going to be false because we haven't gone off yet. So there's like our constructor, and then let's make a way to reset the timer. So we'll make a reset. We need to be able to be mutable so that we can mutate ourselves. And So if we're resetting, then no matter what ready is now, we want it to be false. So I'm not even gonna look at it, I'm just gonna set it. And then time left needs to be reset to time. So duration is a copy type. So these are all copy types. That makes it easy. And then let's make a way to actually move the clock on the timer. So I'm gonna make an update function. Again, we're gonna need our mutable self. And let's take a delta, which is also duration. So that's gonna, every time we go through our game loop, we're gonna pump all the timers with update. So if we're ready, then we're already ready. Like there's nothing to do. We're not gonna get any readier than ready. So we can just stop. Otherwise, let's go check and see if there is some duration here. If we do, so what we're gonna do is duration can't be negative. So it has checked subtraction. So we're gonna take time left and do checked subtraction of delta. So we're gonna subtract delta from time left. And if that goes negative, then it will be a none. And if it stays, yeah, go ahead.
What check subtraction? What was that again?
So check subtraction is like doing time left minus delta. But if you do time left minus delta, and that ends up being a negative number, that will panic and crash the program because durations can't go negative. Just the calculation itself can't. And so what checked subtraction does is it checks to see if you're going to panic. And if it does, then it returns none. And if you're not going to panic, then it does the subtraction and returns it inside of sum. So it's an optional subtraction. Does that make sense?
This is something that is actually, it would be undefined behavior in C if you were to have a signed integer underflow.
Mm-hmm.
So
yeah,
this
but Rust protects us.
Yeah.
And we can try doing it without checking. It just will panic every time our timer gets ready. So that would be really crappy. So here we've got some time, like the subtraction worked, so, and it became here's like our new duration. So we're just going to set it, right? And otherwise we're already done. So we're just going to set ready equals true. We don't care what like the value was because there was no value. So that's when our timer becomes actually ready. So either we're counting down or we hit 0 and we became ready. And that's it. That's like our whole timer. Just, all we really need to do is check when it's ready and pump it with a delta every time through the loop. And then we can reset it whenever we want, whenever we're ready. And then if you keep pumping it while it's already ready, nothing happens. It just stays ready.
And,
so that's our
and this is our timer for like, are you ready? 5, 4, 3, fight.
Sure, if you want to do that, this is exactly what it was before. In this game, we're going to use it for how often do monsters spawn and how often do they move. I think that's the two things I use. Maybe something else as well.
Okay.
Because this is a very, very simple game. All right, so let's go back to main. So we're back in main. Here's our game loop. And before our game loop, let's make a couple more variables. Let's bring our random number generator in here. So our mutable random number generator. Now, fun fact, like a lot of these things that you don't think would need to be mutable have to be because they have an internal state that needs to change. And random number generators are one of those things. And I didn't know that until I started using Rust. We're going to actually use a thread safe random number generator because that's just like the default one is thread safe. That's great. And then we're going to
your two options are to either have it be mutable internals or have immutable globals. And I think usually we prefer to have mutable internals over mutable globals. So, because otherwise your random number generator would return the same thing every time if there was nothing mutating, right? So that's no good.
Yeah, or if multiple threads accessed it, it could do other undefined random things rather than the defined random things that you want. So anyway, so we're going to make a timer now. So we're going to call that timer we just made from milliseconds and got to import it. Oh, it doesn't like it? What if we do this? Aha. Okay. timer from milliseconds. And we're just gonna, the first time we're just gonna say, we always get a monster after 1 second, the first time. And then we'll add our random stuff down in the loop. So, and then we need to start keeping track of that delta so we can pump the timer. So get a last instant. I always do last something as my instant things that I keep track of. So instant now. This is also from the time module. And oh, look, it's already here. Okay, so now we've got our things that we need to use. So let's go use them. So first off, let's get inside of our game loop, but not inside of our other loop, and make our delta. So every time through the loop, we're gonna wanna get our delta, and we're just gonna say it's our last instant dot elapsed. I used to do the calculations manually until I discovered the elapsed method, and that's so much nicer. And then once we've gotten our delta, it's time to start our new instant. So the last instant is now. And that way, you don't want anything in between calculating your delta and your instant. Otherwise, you're going to have this unaccounted for time in between. I've made that mistake before, and I was just like, why is everything running slow? It's weird. Okay. So now we've got our delta. Let's go down below our input handling and spawn a monster. Well, we don't actually have a monster, so we'll just play the spawning sound for now. But we can use our spawn timer. So the first thing we've got to do with our spawn timer is make sure that we're always pumping it with the update delta. Oh, as a side note, like there's a lot of ways to make games. This is a perfectly valid way to make a very, very, very small game or an educational demo. Some people will tell you like, you can't do that. You have to use like a AAA engine for every game. That's not true. You do need to upgrade to nicer engines as you start doing more things though. That is true. Okay, spawn timer. We're gonna check to see, is the spawn timer ready right now? If it is, it's time to spawn a monster, right? At this point, before I do that, I'm gonna make sure to take care of my timer. So I'm gonna go spawn timer. We're gonna set it to a new one. I'm just gonna actually create a new one from millisecond. I could make a method to let you like alter it or whatever, but I'm not gonna bother. I'm just gonna make a new one, and I'm gonna, from the rand library, I'm gonna use uniform. And let's see, did that auto? Yay. I love it when IDs actually work. New. Okay, so uniform picks a random number uniformly in some range. So we give it a low and a high. So our low is going to be 1,000 milliseconds and our high is going to be 5,000. Just arbitrarily saying every 1 to 5 seconds we'll spawn a new monster. And then we gotta go sample and give it the mute. So we defined sort of a builder pattern. We defined the uniform and then we sampled it. And that requires the import of the distribution trait, I believe. Let's go look at that. This is right here, rand distributions uniform struct and distribution trait. You notice I was very meticulous about assigning as many different colors to different things as I could. My orange is struct, orange italics is trait. Blue is enum, and blue italics is an enum variant. Okay, back to stuff. I need to put a semicolon on this guy. And at this point, we would, actually spawn a monster. But we're just going to put a placeholder here for now and play a sound, so at least we can tell it's working. So play monster spawns. And if I did everything correctly, we should be able to go try it out. So we won't see anything, but we should be able to hear whether it's working or not. 1, 2, 3, 4, 5. Okay, that was a long one. 2, 3, 4, 5. Wow, really long. 1, 2, 3. Are they ever going to happen more quickly? 1, 2. Come on, validate us. Give us something more quickly. I'm starting to get concerned. Did I not type in 5,000 for that second one?
I think you did.
Maybe I'm just getting real lucky with really long random numbers. usually this will be really unsteady. Huh. Oh, there we go. Finally. Law of the demo, I guess. Okay. And there we go. So we spawned a monster. So what's next? Next, let's go on to our floor. Okay, so floor. Oh, no, wait, I can't. Sorry, skipped one. We need a coordinate, or just about everything else other than the timer is going to use this coordinate struct that we need to create. So let's start with that. This is just going to define the position on that two-dimensional floor. So it's going to be row and column based. I went row major. That means just rows first on everything. But yeah. So, okay. I'm going to copy in this. I'm going to derive copy, clone, debug, partial, equal, and equal. And then it's going to be our pub struct coordinate. And we're going to have pub row. And in a more intensive game, you probably wouldn't want to use a U size. You probably want to use like a U16 or a U8 or something like that, is just bigger than your biggest possible floor size. But it's convenient for this demo because everything we pass them to wants a U size. So, and then we're going to
so
make
this is a performance thing I've wondered about. Is that true? Because I thought that the way that processors were being developed today is that optimizing for U size was going to give you better like alignments and faster processing than optimizing for memory size.
That's actually an excellent point. And the answer is almost always, most certainly measure it. Everything is so complicated. There are so many things to take into account today, like how efficient is the actual operation? What happens to alignment? What about cache coherency? Would it all fit in the CPU's on die cache or the L1 cache or the L2 cache? Like every time you bump out further, everything gets astronomically slower. Like there's so much to it. Does the compiler auto-vectorize for you under some conditions? Yeah, don't, despite my comments about like optimizing this or that, never jump straight to it. Like do it the most straightforward way first, and then measure it, and then refactor it and measure it again and see if you get an increase, because you can get some real big surprises otherwise. Great point. Thank you for bringing that up.
I just thought that was what you were saying was the way that we were supposed to do it back in the 90s, but it seems like what I've been told recently is that U size is more often than not going to give you the best generic performance. So
right.
Thanks for clarifying.
But it's totally dependent on circumstances. Like if you're dealing with this humongous array, and if you packed it into a U16, it could keep it close to the processor and it could do the process. Like nowadays, right. Instruction processing is a heck of a lot faster than memory access, where it used to be memory access was almost the same speed.
Right.
So who knows? Try it. See if you've gone over a boundary. And also what you find on one set of specific hardware may be different on a different set of hardware. Measure. Okay, anyway, moving onward. We're gonna make a constructor here, new, just make things like a lot more ergonomic when we make these things. So our row and our column, they're both U sizes, and it's going to return self. And all it's gonna do is like pack it up for you so we don't have to type so much. I wouldn't even bother doing this except for we're actually going to do this quite a bit. And then we've got a pub. Oh, by the way, something I highly recommend in general, which I'll just do right now, is going into whatever IDE you have and just setting it to automatically run Rust format every time you save. And then just like the reason I left this here is because I knew auto format would put it up there if I tried to put it down. Okay, there he is. It would put it back up. Maybe it's because of my syntax errors here. Anyway, let auto format do its thing. It's just nice. Okay, so now we're going to make a method for determining. No, we can't do this one. We'll have to come back to this one. We're going to have to do a method for determining direction, but we haven't made a direction enum yet, so that can't do that. And let's see.
What does
We're going
that
to be
first line do? The annotation kind of thing?
this one.
Yeah.
Okay, so what this derives a bunch of common traits that are built into the standard library. Are they core? They're built into something. Copy trait makes it so that if your struct is only made out of copy traits, copy traded primitives, then your struct will become copy, so you won't have to worry about it. You have to derive clone if you're going to derive copy. Debug makes it so you can print out a debug representation of the struct.
So does
And
it
then,
do an automatic implementation for these traits?
yes.
Oh, okay.
Think of it like a compile time macro, sort of. Only
Okay,
it's more powerful.
Thanks.
And
Yeah,
then
so
these
like
two
if you go look at the compiled code, you'll see like the debug code there. Like imagine like it'll spit out another Rust file that says like impl debug for chord whatever.
It's just so dang straightforward. You typing it out would be boilerplate, and
Right.
you know we don't want to have too much boilerplate if we can let it do it for us.
Makes sense.
And these last two make it so we can use equals to compare two chords with each other.
And you need both of them.
I'm not sure.
Of the two. Okay.
You need partial equal at least. Equal
Yeah,
might be required for the comparator.
Equal is mostly just so you can put in things like hash maps and stuff that require you to permit. It's just a marker trait that says it's a total comparison instead of a partial, where like floats nan does not equal nan, and equals a marker trait saying like that's not going to happen.
Ah, cool. Today I learned. I didn't realize. I probably learned and forgot that. So equal is the marker trait one, right?
Equals marker trait. Partial equal is the implementation of the equal operator. So
right. But even though it derived an equality, you might have something in there that's really like, no, it's really different, even if they look the same. But, yeah,
or
anyway.
if you could have multiple things that are distinct but compare equal.
Right.
It would only be partially equal.
Like for this chord, everything within a certain region is equal to each other or something. Okay. Let's make sure I am not locking anyone out of this thing. Okay, not. Everyone is admitted to this room. Okay, so let's see, where were we? We are going to make a method for determining direction in the future, and we're also going to make a method for path finding. But we can't do either of those without direction. So let's go make direction. I'm just gonna actually put it up at the top of this. So again, I'm gonna do all this same stuff and go pub enum direction. And this is just gonna be simple. We're not gonna have any data. It's just gonna be up, down, left, right. And now I don't have to remember like plus what is which way and minus what is which way. We'll just use an enum. And then we're going to go, I'm gonna make a public function. I could make a method on the enum, but I'm not gonna deviate from my demo code here. So I'm gonna call it key to direction. I'm gonna take one of the key events from cross-term and I'm gonna translate it into a direction. So this is gonna be our map. So we're gonna put the WASD, the W-A-S-D, into and translate those into directions. And we'll also put arrow keys on, and I'm actually gonna put in the mappings for Dvorak as well, because I use Dvorak keyboard layout. So we're going to take a key event. Our IDE will find this for us. No. Okay, then. Use cross-term key event. Okay, we're going to return an option, because maybe it's some key that is not a direction. And in that case, we're going to return none. Otherwise, it's going to be a direction. Okay, there we go. It's just being slow. Okay, so we're just going to match on the key, and here's what we got. So the key event could be a character, such as W, or it could be a key event such as up, which is the arrow key, or it could be a key event such as the character comma, which is in the W position on Dvorak. So for all of those, we are going to return some direction. should get rid of my left side here so that you can see this better. Okay, does that make sense so far? So those are 3 patterns that are paired together with or, so that they don't have to go on 3 separate lines. And that's what we're going to return if we hit any of them. And then we're just going to do the same thing for down, left, and right. And then, of course, look at this thing over here. For anything else, for any other thing that was pressed, it's not a direction. So we're just going to say none. So these ones will go it's D, and that is down arrow, left arrow, right arrow, and then, of course, down, left, right. And we don't have a semicolon here, so the match returns its expression. We don't have semicolons here, so the branches return the expression, the match returns the expression. That's the tail expression for our function returns. And what am I missing? Oh, sorry. Dvorak, actually, I got that backwards. The A is the same on Dvorak. And S is O and D is E. Okay.
Isn't S usually down?
S is down in QWERTY. In
Right.
Dvorak. O
Right,
is
but
down.
you have character S or key event left.
I messed it up, didn't I? A should be left. Left is A. S should be down. O.
And you forgot about IJKL for alternately right-handed people.
Yes, but I got to stop somewhere. But yes, you could absolutely add those as well. Keep going forever if you want. Or we could go whole hog and make a declarative config that we would parse. And anyway, yeah. Okay. Got to stop somewhere. Moving on, we've now got a direction. And we've got even a nice way to get that direction out of our input. So we can come back down here to our coord, and now we can determine our direction. So more specifically, I'm going to make this thing called to the, given myself. So on some coord, if I call to the direction, what coord is to that direction? You can see where we're going on this. If I'm a player at a coordinate and I want to go up, I want to ask what coordinate is to the up. So that's direction south. And it's really easy. Just based on the direction, this is the one place where we need to know the math, right? Then if the direction, in fact, we have like a handy IDE feature here. Thank you. There's our comprehensive thing. If it's up.
Okay, that's pretty cool.
Yeah, before Rust, I refused to use IDEs. I just would not use them. And then I tried it with Rust and I was just like, okay, there's a lot of cool stuff here.
How did you do that?
In IntelliJ, if you don't have this here, you do Option or Alt Enter, and then you choose the fill match arms, and then it does it. Okay, I'm gonna fill it out. So no rocket science here. So whoa, I must have had it selected. Stop with the selecting. This is just your basic math. So it's row -1 and call. And then the other ones are really similar, just different. This is a place where, like, when you're doing it the first time, everything tends to be an off by 1 error in some direction. Okay. This one is -1. This is +1. Okay. So we filled out all of our, that gives us back our chord. And again, no semicolon, so it returns. Okay.
What about boundary conditions when you get to the edge?
I had a really simple way of doing that. we just, yeah, you'll see it later. We will get to that, I promise. But now let's do a function 2. So given myself and a target, if I were a monster, say, and I wanted to chase somebody, and I had my own coordinate, and I have a target that is also a coord, right? So this self is the actual object or value I'm called on. This self just means I'm also a coord. I'm going to return a new coord that is towards someone. So the first possibility is we might already be there, right? So if I'm going to dereference myself, if my coord is equal to the coord, we're in terms of coordinates here, then we're there. So there's nowhere to go. I don't want you like to keep moving if you've already reached there. So just like stop. And what did I do wrong? Oh, I just don't, it's probably complaining because I don't have like a return coord yet at the very end. And then what we're going to do, the algorithm we're going to do here is we're just going to move on the axis that's furthest away. So we're going to do a column diff. That's going to be our column as an I32 because we need to be able to go negative here, minus target call as an I32. Row diff equals rows I32 minus target rows I32. Okay, did I get all that right? Looks right. Okay. So what I'm doing here is I'm going to go, if my call diff, if the absolute value of it, so the magnitude of my column difference is greater than the magnitude of my row difference, then if my call diff is less than 0, the direction I want to go is to the, see why we made that to the thing? Right, otherwise we'd have to like do that, repeat that logic in every single one of these branch arms, which would be ridiculously tedious. Otherwise we'd go to the, see the parallels here. Okay, else, row diff, this is really similar. Now we're going to say if row diff is smaller than 0, then it's to the direction down. Else, oops. To the, and these squiggly lines are really starting to bug me. Did I do something wrong up there? The self. What did I do wrong? Call diff, row diff, mismatched types. What did I do wrong, people?
I think it's still
You
that
don't have an
haven't
else
returned
statement on
anything
the
at bottom.
outside.
Or is your if is supposed to.
Oh, I'm unbalanced.
Okay.
Sorry about that. It's probably still unbalanced. There we go. Sorry about that. Okay. So now we have a way to get a coordinate heading somewhere. This is our really rudimentary pathfinding. Like if we hit an obstacle, that would be a problem.
So I had a quick question on the two functions parameters.
This
so
one?
the first one, so the first one's a reference to the self, and the second one is not a reference. That's why you have
Correct.
to dereference it and then compare it with the target.
Correct. So if we try to compare a reference to the target, they wouldn't be things that could be compared.
Right. So was there a reason for the choice of the target to be not a reference?
No, probably could have made it a reference.
Oh, okay. Just a choice. Okay.
I'm not sure. We might have had to deref them both in that case. I'm not sure.
Yeah. Thanks.
Good question. Any other questions? Okay. Well, we don't really have much to show for our chord yet. So I'm going to move right on to our floor. So our floor, get my reference here. Obviously, we're going to use our chord. So create syntax chord. And we are going to have a struct floor. And here our floor is going to be some rows tall and some columns wide. So rows and calls, and we're just going to use the same usize, using that pretty much everywhere we can. And then I'm going to call it tiles, and this is going to be a vector of static stir, which is our borrowed string slice, because I'm going to actually store string literals that are hard-coded into the binary. So, and that's just like super ghetto, I realize, but that's okay because this is a super, super simple game and it doesn't matter. So we're going to implement our floor, and here I'm going to cheat a little bit. First, I'm going to make our new constructor, and it's going to be like how many rows, how many columns, and that's going to return a self. And here's my cheating part. I'm going to copy and paste this because it is a pain in the freaking rear to type in Unicode symbols. So I found all these Unicode symbols and like used some like Unicode picker and like typed in the code point and then copied it out and then came over here and pasted it. And I do not want to put you all through that. But I defined, these are the walls that I'm using for those boundaries. So here's the horizontal wall, the vertical wall, and the corners, all four of them. And then here's like the middle, that is just going to be a space for all the interior of the arena or the floor. And then this is in row major order. Okay, here we just do some fun, set up our vector of vectors. All right, so we're going to make a mutable tiles, which is we're going to stick in here. So it is a vector of type static stir. And we're going to just, yeah, I'm prematurely optimizing here, but I already know the capacity, so I'm just allocating the capacity. We could do new. I mean, we would, on this game, we would not notice the difference, but. And then I don't really need to, I don't care about this, but for this 0 to rows, I'm just going to push all of my columns. So tiles push vec static. Again, we know our capacity, and this time it's our columns. Okay. What did I do wrong? Oh, we're just not to the end of new yet. We need to return a self here at the end. And that's fine. At the end, we will be returning self, rows, calls, tiles. We can already put that in, and then the IDE will stop bugging us. Create the actual floor. But we need to fill it back out first. So let's go back here. And okay, so the first row, that first top row is going to be all wall, right? So first row is all wall. So we can just get the first row directly because we know it's tile 0. And the very first thing is going to be a top left corner. We defined that right up there. See, it went from unused highlighting to used. And that's going to be the first thing. And then we've got for 1 to columns -1, we're going to have to push a horizontal wall. So tiles 0, push horizontal. And then we are at that very last one. So tiles 0, push right. And like, welcome to the glorious realm of game making. Lots of times just like filling stuff out. Now we need the middle rows, right? The middle rows all have vertical walls at the end. So middle rows are vertical sides and blank middles. So a row in 1 to rows minus 1. So that's going through all of the rows that are not the top wall and the bottom wall. Then our tiles at the current row, and they're, luckily for us, they're all the same, so we can push a vertical for the very first one. And then we need, for however many there are, we're not actually indexing in here, we're just using this for the count. For 1 to calls minus 1, tiles, row, push, length. And then we got tiles, row, push, length. I'm sorry, vertical. That's the right side of the wall. Okay, so that did all of the middles, right? And now we've got the bottom row is all wall. So now the bottom row is super similar to the top row. So let's cheat and take that logic, only instead of top left, it'll be bottom left, and instead of top right, it'll be bottom right, and voila, we skipped a little bit. I searched so hard for a more compact way to iterate through this. And even though I found like 4 other ways I could do this, I could use iterators, I could use different forms of loops, they all ended up being more lines, more stuff to type. So settled on this one. And then at the end, we just create the floor and we're all done. We got one other thing here. We don't want to redo the top row, so we also need to go to rows minus 1 here. We can't do rows because that would be 1 past the array, because rows is the size of the vector rather. Now we're getting close to actually seeing something. Before we move on and like make it so we can render this, let's go make it so we can. Oh no, let's go render it. We'll come back and do the methods in a bit. Let's go. Oh no, we need one of the we need the thing that gives us the actual strings, borrowed string slice at the location if we're going to render it. So we need to do at least that one. So let's go get symbol. That's what I called it. It's going to tell us a chord. And chords are copy types, so don't need to use any references. If performance is a problem, we could try references and see if it helped anything. And then we're just going to get out self-tiles, chord row as a, whoa, we don't actually have to cast anymore. These used to be different things. And then chord call. Could have just done that directly, I guess. Used to have some more casts and stuff in earlier versions. So it used to make a lot more sense to have this helper. Okay. Well, that's a lot to do and not have anything to show for it. So let's go start making something to show for it. I'm going to go back to main and go up to the top. And here's what we're going to do. We are going to do a silly little render loop to start with. So I'm just going to go pub render, and we are going to throw this away in the future, but let's get something that we can see. And let's see, what do we need to give it? We will be packaging things up in a world, but for right now, we'll just do a floor. So I'll just do a reference to a floor. So floor is going to be a reference to a floor. Oh, I'm going off script here. See if this even works. Doing things differently in a demo is always fraught, but I'd like to be able to see something. Okay. We've been time. We've been an hour. Take it back. I'm gonna cheat. I don't want this to go over 2 hours because that would be not cool. So I'm gonna go over to render and paste in the final code, and we'll just talk about it, and we'll comment out things that we don't have yet. So let me find things that we need to comment out first, and then we'll talk about stuff that's left. That's good. Okay, we're gonna have to make the world, and then we can print that, and then instead of looping. stuff all out. Okay. So what we've got here is a render loop, and we're going to run this in a separate thread. And we're going to use crossbeam channels to communicate across threads. They're super high performance. They can do a lot of their transfers without even copying anything. We're going to use it in a really stupid way, but it's still going to demonstrate how to use it. What we're actually going to do is we're going to package up everything, including our floor, in a world container. We are actually going to send the whole world over to the render loop, and then our main game loop's going to block while the render loop does its rendering, and then the render loop's going to send the whole world back to the main game loop and then block while it's waiting for the game loop to do its game logic. Like I said, horrible design, absolutely no purpose other than demonstrating sending things across threads using channels. And that part's pretty cool.
How is Crossbeam different from the standard library channels?
Okay, so the standard library channels, MPSC, a lot of the core team feels was a mistake to put in there. It doesn't have great performance. It doesn't have a lot of features. You can do multiple producers, single consumers. Performance is not as good as it should be, and like very bare boned on features. Crossbeam has like just about every feature you could think of, and it's super high performance, and it's what they use in Firefox for all of their channel communication.
So when I think about things that I want in a channel, first of all, I think Go, of course. But like basically I want to be able to count how many things are already in the queue for the channel. Actually, that's kind of the big thing that I think was missing from the standard channels and Rust was just being able to know how much we're in, how many things, not having to keep count separately.
Right. I would assume that's in there, but I haven't actually checked because I haven't needed that particular feature. The killer one for me is having multiple consumers. Because
so is that round robin style?
It's round robin style, yeah. I think, actually, I don't know that for sure. It could be just whoever gets it first. I don't know the answer to that question, actually. But it's not broadcast. Like, it only delivers it once to whoever the lucky receiver is.
Okay. So what I don't want to take us too much off track, but I do want to take us a little off track because I'm curious. Okay. What are the features of Crossbeam that that you like? What does it do that the standard library doesn't?
So it's got bounded and unbounded channels, and then you can use multiple consumers and multiple producers, or single of each, right? And for me, that covers all of my needs personally, and the fact that it's like super high performance. But it's got like lots of other features. I mean, we could go to, it's just Rust Crossbeam.
Crossbeam
itself.
And Levi corrected me. I was incorrect about the counting. I just didn't see it when I was using them.
Oh yeah?
Well, I was talking about Crossbeam.
Oh, okay, sorry.
The counts are in Crossbeam.
Okay.
And there's also a cool select macro for Crossbeam.
Oh yeah. Yeah,
like
that's really cool too. Yeah, you don't get any of that with the MPSC. Let's see what else. Oh yeah, disconnection's nice. Anyway, yeah, good stuff. Okay, anything else on Crossbeam?
So the receiver and the sender, those are the channels?
Yes, so receiver and sender are trait. Whoa, they're supposed to be traits, I thought. Guess they're struct. Receiver and sender though are the channels. Yeah.
Thanks.
So we're getting a little bit ahead of ourselves because I didn't like go make the channels first, and that's because I'm cheating and skipping ahead. So let's go back and actually do some of that. Let's go to main, and in main, right after audio, let's go. So channels always come in pairs. There's a transmitter and a receiver. So this is going to be the channel that the render receives on. I'm just going to use bounded channels, and they need to take a type of world, but we haven't made it yet. So we need to pop up, we need to push on this on the stack as well and go make a world. And if you use 0, the channel actually doesn't have any capacity, and it will block until the receiving end receives. Or some people actually use as a synchronization method to say, like, I don't want this other thread to start doing anything until it gets it. And then you can send like a unit message, which is absolutely nothing, but it will block until it gets it. Well, we won't be sending nothing, but we will be using that 0 size channel, no buffer. And that's because we are blocking anyway. So what's the point of making space to store something that we want to block on?
And in that context, it's basically just sugar around a mutex, right?
I don't know. I don't know how the channels are implemented under the hood. It's a good question. But I believe they make a big deal about these being lockless. So I would be surprised if it actually had a mutex. Because one of the pros of using channels is that you avoid the mutexes, because whenever you get a mutex, that causes all the CPUs to have to sync, which is a huge performance hiccup. And so anyway, that's always been told to me as one of the selling points for using channels. So I would be quite honestly shocked if they were using threads underneath, because that would just nuke the performance. They would, I bet they're still using atomics of some type somewhere though, but I really don't know. Clever people made this. Okay, let's do world real quick. World is super easy, especially like at this point. We're just gonna go pub struct world. It's just a container for everything. So pub floor is a floor. And like, we'll just make a constructor. So world new, we will need rows and calls because floor needs rows and calls, right? Self and, oh, gotta import the thing. And it's gonna be a self with floor is a floor new rows calls. That's it. The other things we make, like player and monster, will also go in here, but it's just a container struct so that we don't have to like type everything out over and over and over in different places. And again, like as you got a bigger and bigger project, that may become the wrong choice later, like packaging everything up like that. But for now, we're fine. Okay, so now we've got our channels. We've got a sender and a receiver. And the reason I've got 2 channels is they're one way. So I'm gonna use the render channel to send to the render thread, and then it will receive it on the render. And then we will pass the render thread the main sender channel, and it will use that to send back to the main channel, which will receive it. So it's our pairs of channels.
One question is, when we're using these channels, I assume, do they take ownership of the value we pass in so that we can no longer use it once we pass it to the channel?
Exactly. That is absolutely correct. That's one of the cool things about channels is you can pass ownership. You can also pass references through it, right? You can pass one mutable reference and that's it. You're sort of locked because you've passed off a mutable reference, or you can pass immutable references to all sorts of places on all sorts of different channels, and all sorts of different threads can read that same data at the same time. It's pretty cool. So like if you had like an immutable config, you could pass it via reference across channels to all of your threads, and they could all have access to that same immutable config.
Nice.
Okay. Render thread. So here we're gonna make our render thread. So let our render thread, which is actually gonna be a join handle. That's what this returns. And then I'm gonna go thread spawn. Okay, I haven't imported thread yet, so let's get that. Now the idiomatic thing in Rust, I don't know why it's this way. For everything but functions, the idiom is to import the actual bare item and use them as a bare item. But for functions, the idiomatic way is to access it through its immediate parent module. So I'm going to do that just because it's the idiomatic way. It's always puzzled me, why is it that way? I don't know. I haven't been able to find an answer. I look for answers to these things because I teach courses about this. So we're gonna call our render loop. That's the public function from, oh, it's not going to auto, why isn't it auto completing? There we go. That was over here in render loop, remember? So there's our world receiver and our main transmitter, because we need to receive a world and then we need to transmit it back over to main. And that really is inconsistent. World, I should have called it the same thing I called it over there. But I called it render, didn't I? Render receiver. Let's be consistent. Render, okay. So render receiver and render transmitter. Now, if we wanted multiple receivers or multiple, I'm sorry, main transmitter. If we wanted multiples, we could clone these, make a clone first and pass the clones over. That's how you have multiple ends on your channel, is when you call clone on the end of a channel, it makes another end of the channel. But we're not doing that here. In fact, that's all we're doing here, I think.
Why do we need like 4 channels?
Okay, so
just the 2.
So the render thread will receive via render receiver, and then it will need to transmit it back to main via the main transmitter. And then main will need to do the opposite. Main will need to receive via the main receiver and send it to the render thread via the render transmitter.
So these are one-way kind of channels?
These are one-way channels, exactly.
Okay. Okay.
That's right. These are not bidirectional. Unlike, say, a TCP connection or something like that, which is bidirectional. These are unidirectional. Great question. And then at the end, we want to join somewhere. So let's just do that right here, render thread join. And if the render thread crashes instead of joining, then we don't care at that point. We'll just crash too. So this is wait for the render thread to actually exit, but it's never going to try to exit if it doesn't know it needs to. And we have a great way to tell it we need to. We're just gonna tell it, we're gonna drop our side of the channel, and that will cause the receive on the other end to get an error. And the only legitimate way to get an error is if the channel is empty and closed. So it'll know, oh, it's time to get out. So that is render channel, so it knows to exit. Okay, so now we've created our channels. We've sort of got a place to send it to, which we probably still need to go comment on some stuff or fix something. But we need to actually do the sending back and forth. So let's do that. Let's see. Send. Let's do that at the end of our loop. So this is the end of the game loop. I'll make this wider again. So this is giving the whole world to the renderer. Render transmitter, send the whole world. And if there's an error, we're just going to crash because the render thread should not be closing before we do. And then we're going to immediately get the whole world back because the only reason, because there's nothing we can do without the world. So we're just going to say, get the world back. So main receiver, receive.
Drop world.
Okay, and then of course, for this to work, we actually got to create a world in the first place, which we have never done. So let's go back up here and create a world. It's gonna have to be mutable so that we can reassign it down below like we just did. So it's a world and we're gonna choose this. I've been using 30 for the rows and 60 for the columns. It gives us roughly a square since in the terminal, the rows are twice as tall about. So now we have a world. Okay, so we created a world, which is that struct. It contains a floor. And then down in our game loop, like we check some stuff, and then we get down here and we're like, oh, now let's go render it because we did all our logic. So we send it across our render transmitting channel. We ignore errors. well, we crash if we have errors. And then we immediately try to get it back, and we block and wait till it sends it back. So let's go over to the rendering side. Take a look at that. So rendering, before we start up our loop, we get cross term ready. So we need this cross term struct. We need to get a cursor so we can control the cursor on the screen. We tell it to hide the cursor. We're not going to be typing and viewing our block cursor. We just need a logical cursor to be able to affect where we print things. And then we're going to draw the entire floor. So here we're going to get, and we're going to do this exactly once because I did optimize some things here. I found that if we redrew the entire floor every time through the loop, it flickered and it was annoying as heck. So instead of that, we draw the entire floor once, and then whenever we like move things, we redraw just specific locations, and it looks really nice. But here, first, we get the world. So we did a render receiver receive. We ignore if we have any errors, because if we have any errors on our very first one, then that's just silly and might as well crash. And then I get some coordinates here for, we're gonna print out the game title later. So I created a new coordinate and I gave it the world's floors rows. So that's sort of the max rows, how far down. So I said, oh, it's rows down, and that's size. So rows will actually be one past the arena, and it's at 0, so all the way to the left. And then I tell the cursor to go up to 0, 0. And then I go and I get out tiles, although I really probably don't have to grab it out. And I say for every row in tiles, remember tiles is a vector of vectors. So first it has a row vector, and then inside of that it has the tiles, which are the actual string slices. And I just print them out. There's probably some way for me to do this more performantly, but this works fine. And then I print out a carriage return. I'm not even sure if that's necessary anymore in this revision. And then, so that prints out the whole map once, and then I send the world back. And then what I've commented out here is like the loop processing everything. We could actually probably add some of this back in. We could repeatedly check to see if we've got the world. Okay, so here we say, okay, we're gonna receive. Every time through the loop, we're gonna receive the world to start with. And if we get the world, great, if it's an okay. If we don't get the world, that's an error we actually wanna pay attention to. That if we get an error receiving on this channel, that means main close the channel. That means it's time to stop. So we might as well break out of the game loop. There's no nested loop here, so I didn't need any loop labels. And we're done. So I'm gonna go down to the bottom, and there's the end of our game loop. And then we just re-show the cursor. Otherwise, back in our terminal, we won't have our block cursor, and it's really annoying. So that is our render for now. And then we've got some helper functions I'll explain when we get to them. So now, finally, we should, if I did everything right, have something to see. Let's go take a look. Typical. Okay, in render, line 37, world receivers, not in scope. Let's go see what we did wrong.
I think you renamed it to render receiver.
Ah, good point. And since it was in a comment when I did the refactor, the IDE didn't know what to do. Cool. And those unused things are because I cheated, and then I didn't do the rest of my imports in main. So I got to do the bounded, yeah. How come it's not finding those? Use crossbeam bounded. Okay, cargo format in action. What's next? Hey, we got our arena. Look at that. Got our corners and everything. So that all works. Hit Q. Hit Q. Okay, well, didn't quite all work. That's unfortunate. So let's go ahead and go PS and kill 85636. Great. Now we're not going to get our cursor restore. So where did we go wrong?
Does Control C not work on that? Is it eating?
Yeah,
Control C?
cross term, we went into raw key mode. So cross term's like, oh yeah, you're pressing Control and you're pressing C. And it's like emitting events that they're being pressed. And we could handle
And then
them
you
right
were
here.
ignoring them.
Yes, and then we are ignoring them right here. The question is, why did this not happen? And it's probably we didn't send back the world. I bet this game input loop was blocking forever, waiting for our render loop to send back the world. Yeah, and we didn't. Whoops, that wasn't what I meant to do. Let's try that again. Hit way too many keys. Okay, so now we're using the main transmitter to send back to the world. And then if that's an error, then main is exited for some reason, and we might as well just break out and clean up. Because like someone controlled seed or something and actually did get handled. Something. So I'm gonna save that. Inside the loop, it is inside the loop, good. Try it again, wrong way. Oh man, I'm gonna have to like redo my terminal because it's in that funky state. But now if I hit Q, yay! There, thanks for playing and everything. I'll go ahead and close this and
the reset command does wonders.
You can just type reset and it'll always go back the way it was.
yeah, sometimes it might work. I will try it next time because it's likely to happen again.
I've had my terminal get in states like that before and reset. I can't even see that I'm typing it, and I just type reset enter and fix it.
I've had times when that worked as well, but I've also had lots of times when it didn't work with this specific program. Okay, we're about the right size. Good stuff. Ignore those for now. That's because I cheated and copied and pasted stuff in. Okay. Moving on. Let's see. What's next? Shall we do the player or the monster? Anyone?
The monster.
The monster. Okay. Monster.
Always
it is.
bet on the monster.
Okay, so we got a pubstruct monster. What does a monster got? Well, obviously he's got a chord. We said everything's gonna have a chord, and that's true. And he's gonna have a symbol. That's what we're gonna draw. I'm just gonna call it a symbol, even though it's a static string slice. And we're gonna have a move timer. Remember we said that they would have timers for when to move. Okay. And let's go ahead and import chord. And let's import timer. And that's all the data we need, at least all the built-in data. I'm going to cheat again. And this time I did a constant because we just want something to select among here. So I did a constant of monster symbols, which is an array of string slices. By the way, you could do this, and then the linchers complain. They're like, a const is always static. This is redundant. It's like, okay, it's true. It works, it compiles, but it's redundant. There's 7 of them. Okay, there we go. Those are the possible monster symbols. Again, a bunch of Unicode stuff. And then we need to implement monster. So impl monster. And of course, I always do my fun new. We need to know where. Where is this monster right now? And we're going to use a random number generator. And we're just going to get a reference, a mutable reference, because we're going to use it, to that one that we made in main. So that is also not here yet. So import that from there. Okay, it's going to return itself because it's a constructor. So we can go down. There we go.
So I'm jumping ahead a little bit, but one of the things that I wanted to do with this game was give the monsters different abilities because they look different, and one should be able to jump or move twice as fast down or something like that, right?
Sure.
So here with the const monster symbols, it is a static array, and there's not. If I wanted to implement custom functionality to associate with a monster, should I instead make like an enum or just put a tuple of things in the array with some sort of attribute, like this is a type 1 monster, type 2 monster, or what would you suggest?
Well, the answer, like many times, is it depends. It depends on how you want to do it. There's a lot of different ways you could do it, right? Depends. Do you want your functionality tied to the symbol? Well, then maybe it makes sense to put these in some type of enum or something. Or maybe you still leave them out here and do what I'm doing now, where like depending on the monster, you sample in a specific symbol if you want them centrally located. So like there's not really a right answer. That's where the art comes into it, right? How do you want to combine it? Good question. Okay, so coordinate we're passing straight through. Symbol, okay, here's our random part. So we're gonna go monster symbols. And then we're gonna make an iterator on the array. And then we're gonna choose, this is a trait method that is added by the, oh, come on, no auto import. Okay, it's iterator random. Iterator random is the trait. And that adds to iterators a choose method that takes a random number generator reference, immutable reference to a random number generator. And then it returns result, I think. Result or an option. So we're just going to unwrap it. We're going to assume that the random number generator always works. And then our move timer is going to be our timer. Milliseconds, and here we're going to use our uniform distribution again. That one imported, yay. And because I'm a horrible person, I'm going to use magic numbers again and say, this is how often the monster moves. So somewhere between every 200 milliseconds and 1200 milliseconds, the monster will move. And it's constant. So some monsters move fast, some monsters move slow. I call sample on that, which is another trait. Okay, imported that. And that's it. We've created a monster in a place. So like, why don't we just stop now and just like have monsters appear? Well, let's see, do we have a way to render them yet? Well, no, we can go add away though. Symbol, we've got the symbol. Yeah, okay. So let's go over to main. And where should we do this? Got to get these in the right order. We got to update the monster timers. So we're reaching, again, like not following all best practices here. I'm tightly coupling my game loop to the logic of my monster. I'm going to say I'm going to update. I'm going to reach right into the monster, access its timer, and update it. So for what? Our world does not have monsters. Let's give our world monsters. So pub monsters is a vector, because we want more than one, of monster. Okay, which means we've got to import monster, which means we've got to go down here and say monsters is a vec. Might be able to infer that. Say new. I'm just being explicit here. Okay, so now we have a vector of monsters. So over in main, we can say for every monster, hold on, in world monsters, and if we stopped here, it would consume all of our monsters. That's not what we want. So let's go get an iter mute, which gives us an iterator over mutable references. Whoa, and I hit way too many keys. Sorry. Gotta be more careful with my hands. And we're going to monster move timer, reaching straight into there and saying update with our delta. Okay. So now our monsters could actually move. That's cool. But we need to spawn them. Hey, wait a minute. We already have spawn right here. To do, actually spawn a monster. We know it's time because it's right here. So let's get a coordinate from it. Once again, randomness, games, randomness, all over the place. So let's call it to coord. It's our place we're going to land. So that's a new coordinate. And for both the row and the column, we're going to do some random stuff. Oh, we haven't imported the coord yet. And good. Okay, so once again, we're using our uniform distribution. I think, yeah, we've already imported that here. Yay. And let's say it's between 1, because 0 is the wall. We just know that. Again, magic numbers. And world floor rows -1. Okay, and then sample. This is going to be exactly the dang same, only it's going to be columns. Okay, so that should give us something randomly anywhere inside of our arena. And then of course, we've got to put our semicolon here. So that gives us a coordinate. Now let's like do one nice thing. Let's say, well, I don't know, don't land on the player. In the past, I've made player first so I could go check and see if we're going to land on the player, but I don't have them yet. So here they come. World monsters, push onto this vector. We've got a new monster, and it's 2 coord is where it's going to be. And monsters need the random number generator as well. Reference to the random number generator so that they can initialize their timer for how fast they move. What did I do wrong here? Expected a mutable reference to an immutable reference? Did we do something wrong?
No, you
here?
just have an extra ampersand in the name.
Yeah, add an extra ampersand right there. Yay, happy. Okay, and audio play monster spawns. Now that should really work. Let's give it a try, shall we? Oh, wait, we won't see anything. Let's make it so we see something. So in the rendering, where are our monsters? Aha. Render our monsters. So I made a little reference here to the alias. Iterate through the monsters. I made a little helper method. I made a little trait for that cursor up here. I made a trait called goToCoord, and then I implemented it for the terminal cursor, so we could just call the terminal cursor with our coord, and it would do the right thing and put stuff in the right place. So then we go down here. So the cursor goes to the right spot on the screen, and then we print it out. And 6 people had to go. And voila. Go back over. Now we can actually run this thing, see some monsters. Yay! Okay.
Sweet.
Pretty cool.
Okay. We're running out of time. What do people want to do? If we want, we could stop here, just chat the rest of the time. If you want, I can start copying and pasting things in to make things go faster. Or I could just keep going. What do people prefer? I've got time. I'm open to anything, even like stopping, whatever you guys want to do.
I say to copy and paste the code in and just go over, explain, and then run the thing.
Okay, absolutely can do. So let's go do player. So copy, player, paste. Okay, so player has a coordinate. A player is facing a direction because he's going to hold the sword out in front of him directly in the direction he's facing, because he's a really bad swordsman. And then the sword itself needs its own sort of coordinate. What is the coordinate? One out in that direction. And then the player needs his own symbol so he can be drawn. And then also we need to know whether or not the player is dirty, meaning the player has moved, so he needs to be redrawn. And then I also threw this player score right onto the player himself. So every time you kill a monster, you get a point. And then we've got a constructor here, takes a coordinate, and it just fills out all those data members. So we just are hard-coded to start facing right every time, and our sword We just set it to also being to the right. It's a coordinate over to the right. And our symbol is this little guy, sort of an onk. And we are dirty because we haven't been drawn yet, so we need to be drawn, and our score is 0. And then we have a little method to get the sword symbol, because depending on the way that we're facing, we'll just look at our own facing, the sword is different Unicode characters. And then we've got a travel. So this takes a direction we want to travel in and a reference to the floor. So we can check. Someone asked about how do we know if we get out of bounds? That's where I check. And we also get the list of dirty coordinates so that we can add things to that list so the rendering can know, hey, these are coordinates we need to redraw rather than redrawing the whole screen. And then we just say, okay, so we're going to travel. We're going to start by saying moved is false. Like, just in case we get through all this, if maybe moved is false. That's what we're actually returning as our Boolean value, whether or not we actually moved. Because we might be like trying to move into a wall and we don't actually move. Okay, so first off, we check to see, am I going to change direction? Like, am I facing some way that is not the direction I want to move? That means I'm changing direction. So I'm dirty for sure. And I'm going to add my sword coordinate, my current sword coordinate, to the dirty thing so it gets redrawn as the floor. I'm going to change my direction to face the new direction. Okay. Otherwise, and I'm doing movement here, either changes direction or it moves. So here's our or. Else I can move because I'm trying to move in the direction I'm already facing. And so in that case, I get the coordinate I'm trying to move to. And then I check, is it a wall? And that's something we need to implement. The floor is wall. So that's the last thing we didn't put over here. So floor is wall. So pub function is wall. And let's just make sure I get this right the first time. A reference to myself, coordinate we're looking at, and true or false. Is it a wall? And the answer is just self tiles chord row chord call is not equal to space, because anything other than a space is a wall, because we've got a very simple setup here. And voila, now we have an is wall. Go back to the player. So if we're not a wall, then we're going to move. So the player is dirty. He needs to be redrawn. Yes, we moved. And the chord is dirty and the sword chord is dirty. And then we switch our chord to the new place we're going to. And then we update our position by actually moving there. And then we return whether we moved or not. And that is the player. And so then we can go back into main, go grab the player. Player moves. So we actually do that right here. So we're looking at keyboard events. So if we get any other keyboard event, K, then we check to see, is it some direction using that key to direction function we made earlier. And if it is, then whether or not we moved is try to travel in that direction. And that means we have to need to get that, did we actually move or not, and create that out here as false so that we can check it again later. Okay, so that will actually do the move. Let's go and see the move. So right here, player. Let's see, player. Let's try to do the right thing. Okay, so here I just made an alias to player in world.player, which means we need to put player in the world. Player new with a coordinate, and we just put rows divided by 2, calls divided by 2. As, let's see, what do those need to be? Oh, it needs to be a chord. that means we're going to import chord. Okay, so that just puts them right in the center of the arena. Pop back out to render. If player's dirty, then we reset dirty back to false and we draw them. So we go to the sword coordinate, then we print out the sword symbol in red, and then we go to the player coordinate and we print out the player symbol in blue. Let's see if that's enough to get this going. Player is not, oh, we didn't create a player in main. We better, wait, no, players created in our world. How did we not get my cursor over here? Cannot find value player in this scope, main 47, when we're trying to travel. 47, nope, main 47, right here. What did I miss? Oh, well, it's world player. Try that. World dirty chords is an unknown field because we didn't add dirty chords. Okay, that's just a bunch of, that's just a vec of chord. So I'm just gonna copy that in. Dirty chords. Part of our world, things we need to redraw. Run. Okay, that's something. We were blank there for a second. Something's not quite working, but a lot of it is. We're not moving our monsters yet, and I don't think we're checking to see if we kill them either yet, but we've got movement. Definitely need to fix up our rendering code, but that's because a lot of it's commented out.
Could turn it into a light cycle game.
Good. Redraw any dirty coordinates with the floor tiles. That looks promising. Comment that. Something's wrong with our player not showing up, but that's redrawing our dirty tiles. Cool. That's weird. Okay, I'm pushing too many buttons. Okay, back to main. Let's see what else we can put in for the player. Player did a monster die. How about that one? And also, we could try to move. So I'm going to paste in to our loop here. It's a monster timer. Okay. Boom. Okay, so here we've got, just to avoid the player crossing with a monster, which is really annoying when you're chasing straight at a monster with a sword, and then all of a sudden the monster hops over your sword and kills you. That's really annoying. So I made it so either the monster moves in a frame or the player moves, but not both. And that stopped the hopping over the sword problem. And then we just iterate through all the monsters and see if they can travel, if the player didn't move. Yeah. And then did a monster die? We check the length of monsters, and then we go through and we use the fun retain iterator method, which is really cool. It actually removes anything from a collection that you don't retain. So we'll retain everything where the monster chord is not on top of the sword. So in other words, if the monster is on top of the sword, we kill him. And then we just check to see what the length of the vector is again. And if it's, or actually we change the length of the vector. And then we check, say, okay, if none killed here is bigger than 0, then we add a score and we play monster dies. So now we should be able to go kill our unmoving monsters. Run. Oh, man. Oh, remember that how I had to change this to world.player up here? world.player. Where are you? World.player. Yeah, that one right there. It's because I had made an alias. So let's just make that alias so I don't have to fix all the places. The player equals a mutable world dot. I think that fix all of those at once. Except for monster try travel. Did we not make that? We did not. Monster try to travel. Okay, so this is the place we want to travel to, or target. And here's the list of dirty coordinates so that if we do travel, we can add some coordinates to be redrawn. And then if our move timer isn't ready, we don't travel, we just return. Otherwise, we do travel. So we reset the timer and we push on the chords that need to be redrawn and we change our coordinate in the to this place towards our target, which is the player. So we could also do things like have monsters target other monsters and chase each other, but we haven't done that yet. Okay, let's try it now. Yes. Boom, and running with the sword. See, before, without that either or moving thing, you'd do this really fast move and you'd die because it'd skip right over your sword sometimes. Okay, but we don't have death code yet. They just get to me and they just give me hugs. So let's go give us some death. Did the player die? That's pretty important. Okay, we're in main. Let's do that after the monster stuff. Okay, so if we go through the monsters, we iterate through them, and we check to see if any of the monsters' coordinates are the same as the player coordinates. That means they're on top of us. If so, we play player dies. We wait until that finishes playing because we're breaking out of the game loop, which means we're going to clean up everything up really fast and exit. So if we don't wait, we'll never hear player dies. And go try it. Die. Still got to go fix our rendering so that we show up eventually. Voila. Death works. That's exciting. We should be about ready to uncommon everything here. What do we have? Player score. Okay, so we format a score string, score, colon, space, the actual player score. We go to that, to rows, so that's down below it. And then we go to calls, which is to the right edge of the arena. And we subtract the length of the string, so we'll be right aligned to the bottom of the arena and print it out in blue. And then similarly with the game title, only instead of being on the right side, it is on the left side. And that's up in game title chord. We computed that earlier. And we're just going to say Rusty Sword, Game of Infamy. And that's going to be in white. Okay, do we have anything else commented out in render? Yeah, then I've introduced some other new bug where I'm not showing up for some reason. Double comments. Okay. Okay, so, oh, interesting. We showed up now. I wonder if that changed something somehow. So there's our Rusty Sword, Game of Infamy in white down here. There's our score in blue over here. And that's all working. And then if we kill things, score 1. Good. Good stuff. And out.
So
and
did you not see the blue character before?
No, before when I did cargo run, it would start blank until things started
moving. I saw it every time.
Did you really?
Yeah.
Wonder if that was lag.
I think.
I couldn't see it for like a half a second or a second. And it was pretty consistent every time we ran it until I'd uncommented those last things. So I don't know what's going on there. But I love how they just run into the sword. Oops, except for that time. That's it. That's the entire thing. We are code complete.
Nice job. That was awesome.
Awesome.
Huzzah!
Yeah, that was pretty awesome.
Thanks.
I don't know if you can hear my clapping through my microphone.